Okay, everyone, let's start. So just quickly go over what we did last time. Okay, let's see. So we have the construction. Suppose we have two intersecting, non-intersecting circles with different radii, and we want to construct a line tangent to both circles. Okay, so here's the first scenario. We have that. We want to find the tangent line x and y so that both circles are on the same side of the line, right? And we can do this. So we can just, the basic idea is to shift xy to PO prime. Okay, I'm going to move this line to I'm going to move the xy to here. So that's what I'm looking for here. I'm going to move the xy to here. So if I, as long as I can construct that line, and then I can get the x and y. So that's what we did last time. Okay. Okay. So let's see. And so that's for here. All right, that's the first scenario. And then another scenario is that where you could also construct the xy so that the two circles are on different side of of the line. Okay. Now in this case, xy, I try to move the xy to again to p o prime, right? So to do this. Okay. Next one, what happens if they're intersecting? If the two circles are intersecting, you can only have one scenario, right? So we don't have the second one here. And then some other examples like that, right? We want to find a P such that P have the same distance. P has the same distance to P and to B and C, and P has a fixed distance to A. So we have a circle here around A, and also we have the perpendicular bisector for BC, and we hope that the two of them can intersect, right? Okay, and how about the next one? The next one is that we suppose we give you a circle and a nine segment with a length k, and we want to construct a isosceles triangle with a base of k. So the base is equal to k, and the triangle is inscribed in that circle. How can we get that? Where so first of all, we can find a nine segment of BC with a length k. That's easy. We can do that. And after that, we can get the perpendicular bisector for BC. So we can get the A here. Right. Okay, what's the next one? This one says that we have R and S. Okay, and I want to construct a right triangle such that the longest side is S and one of the two legs is R. So I want RS to be the two sides of a right triangle, and S is a longest one. So how can I do this? Well, for this, so first, the you can have the AB first. So you can construct the AB first, right? AB construct the AB with a side S, and then you are going to get a circle such that AB is a diameter, right? Why do I need that? Because if I can have AB as a diameter, then I can pick C to be any point from the circle so that this is always the right triangle, right? So this is so C has to be in that circle. And on the other hand, C is also on the other circle around A with a radius of R, right? So the two circles intersect at 2 points, and then we can get the right triangle. The last one is here. Last one is here. So we want to show, suppose we give you a line segment AB and an angle of alpha, okay? And we want to find all of the P, right? There are lots of P here, all of the P here, such that the angle of APB is a given angle of alpha. So where are those points? Okay, where are those points? So let's see how we can do this. How we can do this. Well, for this one, the key idea is the inscribed angle theorem, right? So if I have a P and Q are on the same circle, right, containing the A and B, and then the two angles have the same measure. of the alpha, right? They have the same measure of alpha. So that basically says that for all of the p's, they have to be on the same circle, right? Either it's a circle above the AB, or there could be another circle below the AB. So these are all of the p's. These are all of the p's. But how can I get those that circle? It's actually a part of a circle. It's part of the circle. It's not the whole circle. So how could I get that circle here? Where so here's a construction you can do in the following way. Oh, there's some student here. Okay, so you can just say, okay, how could I get that circle? Okay, so first, you are going to well, let's see. So I'm going to do this. So first of all, I'm going to construct a side of AB, right? So let's see. So first, I'm going to construct a 9 segment of AB. So suppose this is a 9 segment of AB, right? That's a 9 segment of AB. But now and then I'm going to construct a perpendicular line. So this is a perpendicular line here, right? This is a perpendicular line here, right? I can get that. And then from the other side, so from A, I can get a perpendicular line here, right? And then from B, I can get a perpendicular. From A, I can get an angle, but this angle is actually complementary to the angle of alpha. So what does that mean? So what that mean? I just do this. So I'm going to construct the alpha angle here, and this angle is complementary with my given angle, right? I can do that, right? I can use the 90-degree angle and subtract the given angle alpha, so I can get the 90-degree minus alpha. Does it make sense? So from A and B, from A I construct a 90 minus alpha. From B I construct a a perpendicular line to AB, right? And now let me call that C here. So basically, the step one is that the jaw of BD perpendicular with, oh, wait a second. So I have to, so jaw AB, so that AB has a given length, right? Jaw AB. So with a given length, with the given length. All right, second step, I want to draw BD perpendicular with AB. And third, I'm going to draw angle BAD that's equal to the angle of alpha. So they intersect each other. Okay, they intersect each other. Now, I'm going to construct, so I would just construct a circle with AD as a diameter. Okay, so basically you're going to get the midpoint here. So that's a midpoint, right? So draw, let's see, the midpoint, well, maybe just draw, find the midpoint. Okay, so let's see, I'm going to find the midpoint O of AD, right? So O is a midpoint. And then going from the midpoint, I'm going to draw a circle, right? So going from here, we're going to get a circle like that, right? So that will be the circle, and then we're done. So that's a circle, right? So draw, let's see, draw a circle, actually part of the circle with AD as a diameter. And then we are done. Why we are done? Because we're look at that. So this is 80. This is a 90-degree angle, right? So if this is 90-degree angle, then if we suppose that this has to be the diameter here, right? This is diameter. So that's why I want to get the diameter here, and this is 90 degree, right? So if this is 90 degree, this is 90 minus alpha, and then we can figure out that. So then we can figure out that. We know, then we know that D, the angle D, right? Then we know that the angle D is equal to alpha. And also every other point here, right, can form alpha as well, just because they're in the same circle, right? That's also alpha, and that's also alpha. And then so we finish half of the problem. The other half we can do the other side here. So just repeat the same thing, right? Repeat the same thing. I can get another part of that picture. So these are all of the p's here. Does it make sense? Right. Okay, so that's from last time. Now today I'm going to give you some other problems. Okay, let's do again. It's a construction, a geometrical construction. So there are many interesting problems for geometric construction. So let's see. So let's see. Let's try the following problem. So construct problem. Construct a right triangle. I want to construct a right triangle. Okay, such that the attitude to the hypotenuse and the median to the hypotenuse have length R and S. So R and S respectively. Okay, so let me explain that. So what does that mean? So so it says that. So what I want is that I want the following. You get a right triangle, right? You get a right triangle, and the right triangle is here. So let's say you got A, B, and C. This is right triangle, okay? But with the following condition, I want the attitude. The attitude is given. So this is attitude with the names R, okay? And then the median here is the O here, and this is S. So R and S are given. So let's say this is R and this is S, okay? R and S are given. So the names of R and S are given. And what I want is that I want to get the construction of the right triangle such that the attitude to the hypotenuse is R and the median to the hypotenuse is S. Okay, and assuming that S is bigger than R. Okay, so let's assume that we have R is smaller than S. Otherwise, you don't have the answer. Okay, everyone understand that? So how could I get such a triangle here, right? You have the R and S are given, and I want to get such a right triangle. So let's think of that for half a minute. And actually, just remind you, one problem we did. I think we need a one problem from last time. Okay, that's from here. So this one basically says that if I give it R and S, okay, you can always construct a right triangle with the two sides to be the R and S is a non-listed one. Okay, we're going to use this. Okay, we're going to use this. So how do I use that? So first of all, um, I want to construct that right triangle. That can be done. Can you see that? That was just a previous example, right? I just show you, right? I need a right triangle, and the names of the two side names of the right triangle are R and S is the non-least one, right? So that triangle can be constructed, right? Does it make sense? Okay, so first I'm gonna do this. Okay, so first I'm gonna do this one. I'm gonna get the right triangle in this way. So this is R, this is S. I can construct that. Right. So step one. So this is a step one. Okay, I can do this, right? I can, and that's just from last time. From last time, right? I can construct the right triangle with R and S as two sets. Okay. Now all I want here is that, let me call that H here. So this is my O here, this is my H here, and this is my C here. Okay. And then what's my second step? Step two. Step two is that where you have that one here, right? So you have the C here, H here, and O here. And now step two is that you can just make an extension of the 9, right? So first of all, you make an extension of the 9 of OH, okay? And then you need a triangle, you need a right triangle, you need a right angle at the C here. But that's okay. As long as I can make the bottom 9 to be the diameter of the circle, then the top part automatically give me a right triangle. So what I want is that I just go from here, use O as a center, and OC as a radian. So I'm going to draw a circle. So here is my circle. Oops, that's not okay. So maybe I draw the circle like that, right? So I just draw a circle like that. So I draw a semicircle with O as a radius, with O as a center and OC as a radius. And now I claim that this is my A and that's my B. And I just connect AC and connect BC. And I'm done. Okay, why? You think of that then. First of all, you get a right triangle. This is a right triangle. Why this is a right triangle? We say that many times, right? As long as AB is the diameter of a circle, then C can be anywhere from a circle, and we can form a right triangle. So first condition is satisfied, right triangle. Second condition, this is a right triangle. This is a right angle, so that means CH is the altitude to the hypotenuse, and the length of the altitude is R. Okay. Third one, I want CO to be the S and also CO to be the median. Why it's a median? Yes, it's a median because O is the center of the circle. So OA equals OB. So this is the median. So its altitude is here and the median is here. And then we are done. Does it make sense? Okay, give everyone a minute. Okay, I'm going to give you another interesting problem. Let's see. Next one. Okay, here's another problem. So given a square, whose side whose sides each have a length of 4. All right, so you start with a square and with length of 4, right, of each side. Now let's see, we're going to do the following. So let's see, a segment of length 3 moves so that its endpoints are always on the sides of the square. Okay, so let's see, construct the nucleus of the midpoint of the moving segment. Okay, so let me give you an example. Let me draw the picture here first. So first, I'm going to have the square. All right, so that's a square, and the length of the square is equal to 4. All right, we get a 4 here, so 4 from each side. Now I want to have a stick. Basically, it's a 9 segment, right? The stick of the length of the stick is equal to 3, so you get a 3 here. So maybe somewhere is here, right? So this is stick here. So the whole thing is equal to 4 and the 4 here. And then you got the AB, it's a stick here, right? But the stick is moving. Okay, how do I move that? Where when I move the stick here, I want both A and B should be touching the side of the sides of the square. So that means you could have AB in this position, or you could have AB in that position. Can you see that? Right. So it could be B is here or A is here, or it could be you move that one goes here and here, not like that, where my picture was not done. Right, I just try to, so it could be something like that, right? And B is here and A is here, right? So those AB can keep on moving around, right? Moving around. But if it's moving around, I try to find the midpoint of that stick. So the midpoint, let me use M for the midpoint. So the midpoint maybe somewhere here, right? So here's the midpoint, right? Midpoint P, and this may be a midpoint, and maybe another midpoint here. So I got a bunch of midpoints here. So my question here is that I want to find the nucleus of those midpoints, right? All of the midpoints are put together. So where are they? Everyone understand my question? Very good. So let's think of that. It's very tricky. This is a very tricky question. So I want to give everyone a minute, right? If you have some piece of paper, some stick, you can try that by yourself, right? You draw a square here, and you have a small stick here, and you move it around, and just see where are those midpoints, right? If the stick is moving, how can you see the shape of those midpoints, right? What kind of picture it is? All right, give everyone a minute. It's an interesting problem. Okay, so the first, I want to give you a warming up exercise. Basically, so here is a problem here. So suppose I have you this is a right triangle, right? So this is like the AB, right? And the length of that is equal to 3 because the stick has a length of 3. And it's called that C here, right? And here's the midpoint. The midpoint is, so let's see, the midpoint, let me call that M here, right? So M is here, right? So given this is a right triangle and AB is equal to 3. And my question is that I need to find the length of CM. Okay, so can you try to do this one first? Try to do a warming up exercise. So you get a right triangle, right? And then the AB has a length of 3. Okay, see the midpoint. So I only figure out the how how big is CM? How big is CM? Okay, so you get the so you got the AB is equal to 3 and AM equals BM. M is the midpoint. Okay, M is the midpoint. So I want to figure out how, what's the length of this one? What's the length of that one? CM. Can you find? Okay, anyone can get an answer? Yes. Someone says it's a 1.5. You're right. Okay, can you tell me why it's 1.5? Okay, everyone understand that? So some answer, some people say that it's 1.5 in the chat. It's a radians. Very good, excellent. It's a very good answer. So why? Well, so first of all, if I see the right angle, right? If I see a right angle, I should come up with a radius, with a diameter and a circle, right? We talked about that a number of times in the past. Can you see that? So now time we have a bunch of examples. We use that kind of idea. You see that the circle here, AB the diameter, and C is any point on the circle, then ABC form a right triangle, right? And we have we use that idea many times. So what can I do here is that, well, if M is a midpoint of AB and C form a right angle to A and B, so that means I can form a circle here. So this is actually a circle, right? I can form a circle here. It's actually a semicircle, right? So this is so if I draw a semicircle with radians of with AB as a diameter and M is a radians, then C must be on the circle because ACB is the right angle. Does it make sense? Does it make sense? And therefore, so if that's the case, then I will say that CM is just equal to AM and is just equal to BM. That's equal to 3 over 2. That's 1.5, right? Okay. So can you go back to the question here, original question? I give everyone 1 more minute. So I'm looking for, if you have the stick of AB is moving around the square, right? So that AB should be touching the edge of the square. Where is, where are those midpoints, right? The midpoint, so if AB is moving, the midpoint is moving. But where are those midpoints? By using the idea here. So just write down here. So AB is the diameter of the semicircle or the circle, right? It's diameter of a semicircle, right? And then we are done. So M is just a radian. M is just a center, and therefore AB, AM, BM, CM, they are all radians. Okay, so we are ready to draw the picture. So basically, let's draw the picture here. Okay. So the idea is that let's say suppose I have a square, right? And each time if I can have a B with a length of 3, right? And then I have a midpoint. So this is the midpoint of M. And I know that this distance is always 1.5. Okay. As long as AB are on two different sides, to actually, you have to be on the adjacent side, right? As long as AB are the 2 points on the 2 adjacent side of the square, then M must be the distance of 1.5 from that corner. Okay, so if that's the case, then where are the M? M will be the following. I will have my M to be always like, so my M will be uh, always like a 1.5. All of those 1.5 goes here. So I have basically, it's just a fourth of the, 1/4 of the circle. I got the circle here. So this is my circle here, right? So this is a circle of 1.5 each. It's a radius. The radius is 1.5. All right. And so from each corner, I'll measure a fourth of the circle. So this is, let's say, maybe 1.5 here, 1.5 here, and I just draw a corner. So that's a circle here. And here's another circle, 1.5, 1.5, maybe somewhere here, maybe somewhere here. So that is another quarter of the circle. And then here is a 1.5, 1.5, another quarter of the circle, right? This should be the same thing. So where's my picture here? The nucleus will be, you get the 4 of the corner like that. But what happens if A and B are in the same side? If you're in the same side, basically you can have connect this. So the green picture will be the nucleus of all of the midpoint of P, right? So that is my answer. Everyone's okay? The green picture is the nucleus of the P. Okay, the green picture is the nucleus of the P. Right. Why we have the AG here? The AG is actually if the A and B are from the same side, right? If A and B are from the same side, then it will recover the AG here, this AG and this AG and this AG and this AG, right? So connected together. So this is the movement of all of the midpoints of the AB, right? The AB will be moving this way. So if you move the stick around, and AB where the midpoint will be moving that way, right? That's very, very, very interesting. Okay, very cool. Any question? Right. So we use the property again, right? If you see a right triangle, then the hypotenuse is the diameter of that particular circle, right? Keep that in mind. We are going to use that a number of times. Okay. Any questions so far? Good. Let me ask you the next one. The next one is easy. So let's say, suppose, so the next problem is, okay, suppose I want to give, so given unit length, a unit length. All right, so what does that mean? Suppose I tell you this is 1, okay? This is a unit length of 1 unit, okay? If that's a 1 unit length, then I want to construct a 9 segment of length square root of n. Okay, where's n? N is just a positive integer. Where n is a positive integer. So what does that mean? So this basically says that what kind of a length can you construct it, right? You suppose you have the 1 here. If you have 1, certainly you can do the 2, 3, 4, right? So if I get 1, I can get 2, I can get 3, I can get 4. So that means all of the integers are okay. or integers, actually positive integers, or positive integers can be constructed. Constructed, right? Does it make sense? Right? Just add one, add one, add one. So you have all of the integers, not a problem. And then the next question is that, can I construct the square root of all of the integers? Right? That's just the next question. Okay, give everyone a minute. So for example, can you construct square root of 2? Can you construct square root of 3? Right? Can you construct square root of 4? Well, square root of 4 is 2. It's easy. Can you do square root of 5, square root of 6, square root of 8? Right? Okay, so give everyone a minute. Can you have a systematic way to construct the square root of each integer, each positive integer? Okay, any question, any suggestion from the previous one? How do I get square root of 2? Well, square root 2 is easy, right? So if you can get 1 here, so let's assume that. Suppose I get a 1, right? So let's assume, right? So let's say, suppose I have, okay, suppose I have 1 here, right? Suppose this is a 1. So if this is a 1, then I can get, so this is a 1 here. I can get a perpendicular line here with 1 again. I can get the square root of 2, right? That's a Pythagoras theorem. Can you see that? Right, so 1 and a 1, I can get square root of 2. How could I get square root of 3? Where I do the same thing, right? I just do the same thing. So, so that means I'm going to draw another perpendicular line with the length of 1, so I can get the second triangle, right triangle, so that the length is equal to square root of 3. Square root of 4, same thing. It's actually 2, but the things I want to do I want to do square root of 5, so I have to do like that. So this is a 1 again, and this gives me square root of 4, and the square root of 5, I can get the 1 here, and so this is the square root of 5, and I can get the 1 again, and this can give me square root of 6, and so on and so forth. So that's the way here. So basically, you just go, each time you're going to draw the next right triangle, right, with another side, another leg of 1, right? The unit leg, right? The leg has the unit length of 1. And so the hypotenuse will be square root of 2, square root of 3, 4, 5, 6, and to infinity. So far, all the square roots are constructible, right? Does it make sense? Right. For any integer, I can construct the square root of that of that integer. So that's a geometric construction. Uh, how about next question? Next question is tricky. I have R and S. Okay, R and S may or may not be integer. So R times S may not be an integer. R may be just any given number. So suppose I give you two 9 segment R and S. Okay, I want to get the geometric average, right? That's called geometric mean, right? So the square root of R and S. Can you get that? How can you get that? So suppose R is given. So this is a R, the length of R, and the other one is the length of S. Can you give me a 9 segment with the length of square root of R and S? So that's a geometric mean. I need to get a geometric mean of two numbers. Is that constructible? Right? That's an important problem in geometry, right? You have a arithmetic mean that should be okay, right? You add R and S and take the midpoint. That is just the arithmetic mean. So by the way, R plus S divided by 2, that should be easy. How easy? Where you can go from here, right? You can go from here. Suppose this is your R and this is your S, right? You get A and B here, and then you just get the midpoint, right? So get midpoint, get the midpoint of AB, and then we are done, right? You have the length of R times R plus S, right? And then just get a midpoint. That should be okay. And now for the geometric mean, how do I get the square root of RS? This is tricky. Okay. I'm going to give a warming up exercise. Again, I'm going to give some hint here. Here's a hint. The hint is the following. So if I can have a right triangle, again, the right triangle is very, very important. So suppose I get a right triangle here, and suppose I get this one like that. So suppose these R and S. So let's say this is A, B, C, and D. Everyone is okay? So R is here and S is here. My question is that, can you find the CD? Okay, this is actually an example from 07 algebra, 07 geometry last semester. So if you were in my previous class, that's the example from the previous class, right? Do you remember that? What's the length of the CD? The length of the CD is actually the square root of RS. Okay, why? Well, we can prove that we don't have time to go to detail because it's just in the previous class. And let's see. But the goal is that you are going to show this triangle, okay, the red triangle here, and the green triangle. The two triangles are similar triangles. Okay, can you tell me why? Why the two triangles similar triangles? Well, one obvious condition is here. You have the right triangle. You have the right angle here. The two right angles are the same, so that's one pair. But I need another pair. Can I prove this guy is equal to that guy here? Okay, let's see. Put it back here. Can I prove this guy is equal to that guy? The two angles are the same angle. Why? Where? So this is because okay. So angle A is 90 degree minus angle 1. So this is called angle 1. Okay. But at the same time, that's also equal to angle 2. Can you see that? So angle A is a complementary to the angle 1, and angle 2 is also complementary to angle 1. So that's why angle 2 and angle A are the same. And therefore, we get a second condition. So the two triangles are similar triangles. So we have the triangle of ADC. Okay, ADC is similar with the CDB, right? That's a AA condition. And if that's the case, then we can say that the AD over CD equals a CD over a BD. Can you see that? Right. So first I have the AD, right? AD is here, but what corresponds to the AD in the other triangle? That's just here, right? You got this. That's one thing. Okay. And another one is that you can have this side correspond to that side here. Okay. But the problem is that CD is used twice. So CD squared is AD times BD, and therefore CD is the square root of the AD and BD, and that's the square root of RS. Can you see that? So all I want is that I want to make the AD to be R and BD to be S, and the CD has to be the geometric mean. Okay, so that's the idea. Okay. So here's a question. What is this? Is CD R plus S? No, CD is square root of R and S. CD is a geometric mean. Right? So I want AB is R plus S. So AB, so this guy here is R and this guy here is S. Okay. So CD is that the geometric mean. Right? Okay, so let me so that's the idea. And if you understand the idea, now let's do the construction. Okay, so how can we do this? Maybe give everyone a minute. Okay, so use this idea how to construct your CD. Well, you need a right triangle here, right? If you run a triangle, the right triangle, how do you construct such a right triangle? So you need a semicircle, right? You need a circle with AB as a diameter. Again, we use the idea again, right? So this is the idea. So let's do it. So construction. Okay, so first of all, I'm gonna get my R and S. So this is A, this is B, this is D. Suppose this is R and this is S. Can we do it? Yes, certainly we can do that, right? So we can have. So first of all, I can do this. Okay. And secondly, I'm gonna construct a circle, actually just a semicircle, right? I'm gonna just construct a semicircle with AB as a diameter. So basically, so step one, right? Just make AD equals R and BD equals S. Okay, step two. So draw a semicircle with AB as a diameter. Right? How can you do that? Where you can do it? You can first get the center, right? The midpoint, and then going from the midpoint, you use a compass to draw a circle, right? Everything's okay. We did that, some time ago. So let's say, suppose this is the midpoint here, right? And then I can get my semicircle somewhere here. So let me draw my semicircle. All right, I get my semicircle here. And now, after I get my semicircle, then step three is that you can draw a perpendicular line. So this is a perpendicular line. So draw the perpendicular line in this way, right? And intersect at the point, and then we are done at the point of C, right? So draw CD perpendicular with AB, and then we are done. So CD is just a square root of R and S. Okay, why? Just because if we have that, then we have the hairpin line. The hairpin line will be, I get here, right? I connect the BC and AC. And then this is a right triangle. And then it's just a previous problem. Okay, just a previous problem. Can you see it? So let me give everyone 30 seconds, right? And I'm going to move to another problem, which is very, very important in the history of mathematics. Okay, history mathematics. So we are going to talk about some very important problem now. So the next problem is very important. So that is a construction of the regular polygon. Okay, that's very important. So let's see. Next one. So here is very important in the history. Okay, so important an important problem in the history of mathematics. All right. So the question here is that basically is that how to construct, okay, how to construct the regular polygon, okay, regular polygon of, let's say, n side, okay, of n sides. Where for some of the n and some of the problem may be easy. So for example, some of the easy problem may be n equals 3, right? Equilateral triangle, everyone can do it. 4, that's a square, everyone can do it. Okay, 5 is not easy, we can still do it. So we got durable. So let me say durable, but not that easy. So n equals 5, we can do it. Okay. Let's say 6. How we can do 6? Why 6 is okay? Can everyone hear me? You can do 3, you can do 4, right? So how can you do 3? Uh, for 3, I think it's okay, right? If you have that circle here, right? This is a equilateral triangle. How can you do 6? You just do the perpendicular bisector, like here. Perpendicular bisector, perpendicular bisector, and you can connect this one, this one, this one, this one, this one, and this one. All right. So you can always multiply by 2, right? If you can do the regular polygon of 3 sides, you can do that for 6 sides. You can do that for 12 sides, 24 sides, and so on and so forth. You can always multiply by 2, right? If a small number is durable, then multiply by 2, double it, you can still do it. So just double it. So this is just a double, 3 times 2, right? That's good. All right, and 7 is actually not durable. So undurable. Okay, n is equal to 7. Okay, 8. Can you tell me 8 is 8 okay or not? Is 8 durable or not durable? Yes or no? I'm talking about 8. If n equals 8, can you construct a regular polygon of 8 sides? Octagon. Yes or no? 8 is actually durable. Why 8 is durable? Because it's a 4 times 2, right? You can begin with a square, right? You can begin with a square and then you just cut that into half, right? So 9. How about 9? 9 is actually not. You cannot do the 9, okay? And 10 is actually durable. Why 10 is durable? Because if you can do 5, you can do the 10, and vice versa, right? If you can do 10, you can do 5, right? So these are the numbers up to the 10, okay? Well, there's actually a theorem here, but anyway, so that's all you need to know. So if you can, you tell people that up to 10, you tell people what kind of a regular polygon can do, what kind of regular polygon cannot do, right? That's enough for this course, okay? But now, today, in particular, I want to show you how to construct that one, okay? The regular polygon of five sides and 10 sides, okay? Regular pentagon and a regular decagon, okay? Decagon. So where I just want to choose one of this because if I can do one, I can do the other one. Does it make sense? It's just doubling or halving, right? So I just decided to do, and today I want to do the, how much time? Well, not much time left. Okay, anyway, so let's try my best. So I'm going to do, so today, let me do n equals 10. Okay, someone can do the n equals 5. If you can do 5, you can do 10. If you can do 10, you can do 5. Does it make sense? You're equivalent. So let's see, how can I do the 10? So I'm going to show you the idea first. Okay, as long as you get the idea, you can get the construction very easily. That's not a problem at all. Okay, so let's try that. So here's the idea. The idea is that where, so uh, if I have a circle, all right. Suppose I get a regular polygon of 10 sides. All right, so this is one of this. Suppose this is, let's say, I'm going to get the 10 sides. This is a B here, and this is a O center, and I get that one here. Suppose this is one, this is one. So I'm talking about a unit circle, right? I want to construct a regular decagon inside a unit circle. All right, so the radius is equal to 1. So the question here is that if I can find AB, then I'm done. I just need to find AB. Does it make sense, right? If I can find AB, then I can construct that, right? Okay, so the question here is how do I figure out, right? Okay, in order to get that, so my first question is, can you tell me what's the angle of O? What is this angle here? Any suggestion? I want to find the angle here. So what is that angle of O? The central angle here. Well, keep that in mind. If you don't know it, you have 10 sides, right? All of the 10 sides, they are just equivalent. So the central angle altogether, you have 360 degrees, and you divide that by 10, that's equal to, so that's 360 degrees divided by 10, and that's 36 degrees. That's cool. Okay, so I know that this guy is 36. How about this guy here? Angle A, where angle A and angle B are the same. Does it make sense? Okay, so I get 180 minus 36 divided by 2. Sure, that's 144 divided by 2, 72 degrees. Okay, so I get 72, I get 72 degrees. Now, you should be able to figure out the AB now, okay? So let's see. Let me give you, make the picture bigger, all right? So you get a very big picture, and so that you can see it. I'm going to get this one here. All right, that's A, B, and C. A is 36 degree. B and C are 72 degrees. And AB and AC are equal to 1. So how could I get my X value? So this is X here. So the question here is that I want to figure out the X, right? If I can find the X value, I'm done. Does it make sense? Okay, give everyone a minute. You should be able to do it. Okay, I'm going to give you a suggestion just in case. Here is the just draw a angle bisector. So let's draw angle bisector here. So I'm going to draw angle bisector. So BD is an angle bisector. So it's an angle bisector. Okay, I think that should be enough hint for you. If the angle bisector, this guy is 36, the other guy is 36 as well, because the base angle is 72. You see that? So cut that into half. So that's a 36 and 36. All right. So you got the 36 here, right? So that's a 36 here, right? And how about this angle here? So this is 72, right? How about this guy here? How about this one? The question mark here. The question mark is 72 as well, right? You just use the either the triangle sum theorem or you have the exterior angle theorem, right? 36 plus 36. So this is 72 as well. Cool. And now, so you have the baseline has a length of x. Can you tell me you can write x in some other line segment? There are actually 3 line segments which are also x, okay? There are 3 line segments which are x at the same time. You have lots of You have lots of isosceles triangle. Does it make sense? Okay. So I give everyone 1 minute. So can you label those x values in the picture? So this is x here. This is also x, right? Because it's we have our isosceles triangle, and this is also x here because 36 and 36 here. So I'm going to remove that one because this is confusing. Okay, so basically this is a 1 minus x. All right, you got that. Now the next suggestion is to find a similar triangle. Can you find a similar triangle? Okay, let me suggest you. So I wanted to show you. I wanted to show that the triangle of ABC. All right, this is a 36, 72, 72 degree triangle, and that should be equivalent. That should be similar, right? With the with what? So with the BCD, right? Why they are similar? Because they have the 36 degrees, 72 degrees, 72 degrees, right? They have similar angles, right? So if that's the case, can you set up the equation? Okay, set up the equation. You can solve for the x value. Okay, let's do it. Right? Can you do it? So basically, I have the AB, right, over the BC, and then BC over the CD. Okay, so what is the AB? AB is equal to 1. BC is equal to x, and BC is x here, and 1 minus x. So this gives me the x squared equals 1 minus x. And so I get x squared plus x minus 1 equals 0. And now we get a quadratic equation. Solving this equation, everyone can do it. Okay, so what's x here? X is just a 2 here, right? And then -1 and then plus, right, square root of 5. There's also -1, negative square root of 5, but that's not good because x has to be positive. So we are done. Why we are done? Because just tell me how to construct the square root of 5. Well, we know it, right? The previous problem just tells you that how to get the all of the square root, right? So square root of 5, we can do it, right? If I can do square root of 5, then I can do the -1, certainly, divide by 2, certainly take us. And then if I can get that number, then I just measure that number along the circle, and we are done. Does it make sense? Right. Okay. Let me quickly give you the construction. Uh, we don't have much time, but I'm going to try to get the construction. So here is the construction. Okay. So let's see. Suppose I get a very big circle. All right, let's get a very big circle here. And I can draw the certainly perpendicular line, and this is the center, right? Okay, first of all, I can get the midpoint here. So this is 1/2, this is 1/2, this is 1, right? Not a problem. And I can connect this. So this is a perpendicular line. I can construct this one here. So by the Pythagoras theorem, right? So this one is a square root of 5 divided by 2. Does it make sense? Right? And then I'm going to do the following. So I'm going to go from here as my center. This is M at the center. And then I just draw the circle in this way. Okay, cut here. Can you see that? So this is the center. Okay. So I go from here. M is a circle. M is a center. And the root of 5 divided by 2 is a radius. So the question here, what is this number? What is this number? Can you tell me? This number is just the square root of 5 over 2 minus 1/2. And we are done. So this is exactly what we are looking for, right? So that length is just the side length of the regular decagon, right? Okay, we're done. So just give everyone a few more seconds, and we are done it, right? Okay, are there any questions? Any question? Are there any questions? It's pretty hard. Again, for those constructions, some of the questions are not easy, right? But you need to look at your notes, right? And so for the next 2 weeks, we don't have class because of the spring break, right? Spring break. So 2 weeks we don't meet. We don't meet, and the next meeting will be, I think, will be in 3 weeks, right? So it's 3 weeks from today. That's our next meeting. All right. So if you don't have any question, I'm going to end the meeting. So see you in 3 weeks. Okay. Bye, everyone.
Bye. Thank
Thank you.
thank
Bye.
you.
Mhm.